Hey, Physics Boss Man coming back at you. And you can do physics like a boss too if you practice a lot. A girl throws a tennis ball upward with an initial velocity of 4 meters per second. What is the maximum displacement of the ball?
God's
help. You can do physics like a boss because you are created.
You are created in God's image.
To be fruitful and multiply.
Fill the earth and subdue.
Okay, so to interpret this problem, we want to draw a picture. So we've got the ball going upward with the initial velocity of 4 meters per second. The direction's upward, of course. Let's go ahead and put in our coordinate system here. So this is x horizontal, y is vertical, and we know intuitively when a ball is thrown up, it's going to reach some maximum height. And see, y initial equals 0, and we'll consider 0 meters, y maximum as the final y. And so let's think about this a little bit. The general principle, what's the general principle here? Well, the general principle is this idea due to Galileo that in the absence of air resistance, all objects near the surface of the earth accelerate downward at 9.8 meters per second squared, and I just call that constant g.
God has crowned you
You
with glory and honor.
Honor to rule over his creation.
Creation.
Alright, so now to develop the problem, because we're using our idea problem solving framework: interpret, develop, evaluate, assess. So the first thing we're going to do is we're going to compute the time it takes to go up, but we're going to use something here. We're using the idea that V final equals 0, and let's think about this for a minute, because at the top of any object's upward motion, the y component of its velocity is 0, and here's why. If the y component were still positive, it wouldn't be at the peak because it'd be still going up. And if the y component of the velocity were negative, it wouldn't be at the peak because it'd be on its way down. The peculiar property that all thrown objects have at their peak is that their y motion, their vertical motion, has stopped just for that instant, and we can use this to compute the time it takes to go up. And so then we can use the time it takes to go up to compute the y max. Alright, now evaluating this.
Science is a gift from God
To help us master nature,
but sin added thorns and thistles.
requiring the sweat of your brow to succeed. So we know that V final equals V initial minus GT, and this is just the kinematic equation for velocity in terms of time, but we're going to set this equal to 0 as a choice that we reasoned through earlier. So V initial minus GT, and this isn't just any t now, this is T max, or T up is what we called it earlier, equals 0. So we get minus g t up. Go ahead and subtract v initial from both sides, equals negative v initial. So now we're solving for t up is equal to minus v initial divided by negative g. The two minus signs cancel out, so we can go ahead and plug in the 4 meters per second divided by 9.8 meters per second squared. So that yields t up is equal to 0.408. Now we're expecting seconds, but let's take a little care here. Let's not just write down units because we expect them. Let's go ahead and we have meters per second over here, and then when you divide by a fraction, it's like multiplying by the reciprocal. So the meters cancels out with the meters, and one factor of seconds in the numerator cancels out with the seconds in the denominator. And by doing the math carefully on the units, we do confirm the expected seconds. So now,
learning physics
often requires prayer
as we submit
to Jesus Christ
as risen.
as risen King of Kings and Lord of Lords. Y final equals Y initial plus V initial times the time minus 1/2 GT squared. Well, what's Y initial? Well, we set our axes on the ground or at the point where the ball was released from. So Y initial is equal to 0. And then V initial times the time is the 4 meters per second times the 0.408 seconds, which was the time the ball spends going up. And then minus 1/2, well, I'm going to go ahead and write it below, I'm running out of room, minus 1/2 9.8 meters per second squared times the times the 0.408 seconds quantity squared. Alright, so you punch that into your handy dandy calculator and you get 0.816 meters for the final height. Now let's also take a little care with the units. Meters per second times seconds, that's units of meters. And then we have meters per second squared times seconds squared, so that's meters also.
We reign by surrender.
We reign by surrendering to Jesus and praying for our daily bread, which includes success
in our schoolwork.
God will answer and lighten our yoke and the impact of the thorns and thistles in our labor. Alright, so let's assess this answer to see if it makes sense. Does the sign of the answer make sense? Well, the sign of the answer is positive, and if you throw a ball upward, of course its final height at the top of its motion is going to be positive. Is the units right? We took due care with the units and we computed that the units would have units of meters, and it does. What about the magnitude? Well, it kind of makes sense qualitatively, right? You throw something up, the idea that it might go up a little less than a meter, that makes sense, but we can be a little more quantitative than that. We can use the kinematic equation without the time as a double check. V final squared equals V initial squared minus 2A delta Y. Alright, so now V final squared is 0, and we're not going to assert this is true and solve for something. What we're doing is we're checking to see that it's true with all the inputs that were given. So is 0 equal to 4 meters per second quantity squared minus 2 times g, because acceleration is g here, and now times delta y, which is the 0.816 meters. So checking the units, we have meters per second squared, or meters squared per second squared, and then meters per second squared times meters is also meters squared per second squared. So the units are the same, and then when you do the math in the numbers, 4 squared is 16, you multiply this out, you get 15.99. Within the rounding errors, this equation checks out, so it passes our assessment. And let me encourage you that physics is getting good at physics, doing physics like a boss, is like practicing a musical instrument, or playing football, or shooting free throws. It requires practice. Nobody is really born good at physics. But with God's help and with prayer and with diligence and practice, just like you can get good at piano or get good at free throws, you can do physics like a boss.
Written in the Word, in the good, good Word is a message from our God. Gonna tell you all about how to get to the kingdom, the good life. Written in the Word, in the good, good Word is a message from our God. Gonna tell you all about how to get to the kingdom, the good life.